So we're going to jump around a little bit through chapter 13. You can see yesterday we did 3 and 4 or 2 and 4 because they went really nicely together. Today we're going to do 6 and 8 because they go really nicely together. They're both all about probabilities and outcomes if you roll a dice or you flip a coin or you spin a spinner or all of that. So they went really nicely together. So I paired them together. On your homework, I have everything whited out that I want you to skip, and I didn't leave you too many on each one to do. So you'll do everything on the front and the back that's left. But like I said, I whited out most of the problems. So, all right. So a couple of bits of terminology here that I want to talk about. Theoretical and experimental probability. Okay. Those are really big mathy words, but they really don't mean anything too hard to understand. Theoretical probability is what should happen. So that means it's just the raw numbers. If you flip a coin, what's the likelihood of you flipping a head? 50%. So if you flip a coin, the theoretical probability is that 50% of the time you're going to get heads. Now, if I were to actually hand you a coin and have you flip it 10 times, you might flip heads 60% or 75%, right? And it's going to change. And then you might do the experiment again, and you might get 30% heads. So that's what experimental means. It's what actually happens, what should happen and what actually happens when you play out the experiment. Okay, that's the difference between theoretical and experimental. Damien, you got it? Got those two things written down? Okay. Now, probability. There's a formula for figuring probability, and you will definitely want to make sure that you have this formula down. Okay. It's the number asked, and I'll tell you what I mean by that in just a minute. Okay, it's basically the probability that you're asked about over the total number possible. So if I ask you, what are the total possible outcomes of flipping a coin? How many are there? There's 2. There's heads or tails. If I asked you, what are the chances you flip heads? It would be 1 over 2. Okay, there's a 1 out of 2 shot that you're going to flip heads versus tails. So the number that you're asked about, and it's in the book, and when you might read about it, like on an iLearn, it'll say the favorable outcome. It just means the one that you're wanting, right? So if you're asking about heads, that's the favorable outcome because that's the one you want. So it's the favorable outcome or what you're asked about over the total number possible. So if we look at this spinner here, I want to call your attention to a couple of different things. Okay, reading the directions is really important. It says the spinner is used in a game. Determine the theoretical possibility. So that means just the what should happen, okay, of each outcome if the spinner is equally likely to land on each section. And then notice this last sentence. Express your theoretical probability. Here's the important part. As a fraction and as a percent. So you've got to watch your directions because sometimes it asks you for the probability as a fraction and a percent. And sometimes it just wants the probability. And in that case, it's just left as a fraction. Okay. So in this first one, first of all, notice in our equation, it's the number that we're asked about or the favorable outcome over the total number possible. Well, before we even look at what the favorable outcome is here, let's look at what are our total number possible of outcomes if we spin the spinner. What would it be? 16. Because there are 16 spots, right? All equal in size, all equal probability. You spin it, you got a 1 in 16 shot of landing on any one of them. So it wants to know the specific probability of landing on just a 15. Well, how many spots are there on the board that say 15? 1. So you have a 1 in 16 shot of landing on the space 15. Now to put this in your calculator and make it a percentage, and everybody should have a calculator. If you don't, 30 seconds to grab one. Okay. Huh? Nope. Doesn't matter which one. Just grab the closest one you can because we're going to do it the same way in all calculators. So our first answer here is a fraction, right? 1 over 16. That's the fraction expression of our probability. Now we're going to express it as a percent. And to do that in your calculator, I want you to put 1 divided by 16. Now that is going to give you a decimal. That is not a percent yet, right? So I'm going to write this out here, what I got as a decimal, 0.625. How do I change a decimal to a percent? Yeah, I bounce twice and I put my best decimal point in the new place. And so my percentage here is 6.25%. And that's what you circle as your answer, those two, the fraction and the percent. Now, I will say this, if you want to skip this step in your homework as far as writing it, I'm fine with that. When you punch it in your calculator, if you can convert it to a percent just from looking at your calculator and bouncing, I'm fine with that. So, but if it helps you to write it out and then bounce it on your paper, then that's fine too, okay? All right, so number 2, it says, what is the probability of even? Well, again, what's our total possible? 16. How many even chances do we have? So count how many even numbers you have around the spinner. 8. We always reduce fractions, so that's 1/2. And then what is the percentage equivalent of 1/2? 50%. Good. So we're going to circle or square 1/2 and 50%. Always reduce fractions. And then in this case, because it wants it, you're also going to express it as a percent. All right, how about greater than 10? Well, think about what numbers on here are greater than 10. It's not greater or equal to, it's greater than 10. So that would be what? 1, 2, good, 3, 4, 5, 6. There are 6 spots here greater than 10. So it would be 6/16. We reduce that. And because they are both divisible by 2, right, we're going to reduce that to 3/8. That's half of our answer. Now in your calculators, you're going to take 3 divided by 8 equals, and then you're going to bounce twice. So we're going to go around the room now and everybody's going to help out a little bit here. Braylon, what'd you get when you put that in your calculator? Okay, so how would you convert that to a percentage? 37.5%. And that's what you circle as your answer. Good. All right, let's look at number 4. It says the probability of spinning a perfect square. I'm going to erase what we just did. Now, which of these numbers on here are perfect squares? Blake, tell me one. 9. Okay, 9's a perfect square. What else? Somebody else tell me one. Sophia? 16's a perfect square. There's 2 more. What's 1 times 1? 1. What's 2 times 2? 4. 3 times 3 is 9. 4 times 4 is 16. So those are our perfect squares. So we had 4 out of 16, which we're going to reduce that, right? Both of those are divisible by 4. So we get 1/4. Yeah, so 25%. 1 divided by 4 is 0.25. Bounce, bounce, and you get 25%. How about shaded? Count how many shaded you have. 7. Can that be reduced? Okay, so in your calculator, 7 divided by 16, bounce, bounce, and we get what as a percentage? Damien? Good, 43.75%, and those are the 2 answers. Pretty easy there? All right, these are called simple probabilities, meaning you've got one thing you're doing, right? You're not rolling a die and tossing a coin, which is what we're going to be doing here in a minute. It's one simple probability. All right, so we talked about theoretical probability. Now somebody actually took this spinner and they spun it 50 times. Why is that important? Right, and what's our total number of outcomes at the bottom now? Out of how many spins? So what would our bottom number of all of these be? 50. They spun it 50 times, and we want to know the probability of landing on, okay, this is the experimental. This is not one spin. When it's one spin, the probability is 16 lands. But now we've got a total experiment. So now the bottom number isn't 16, because now this person spun it 50 times, and we want to know the probability out of those 50 spins, how many times did it land on? And then we've got 4 different favorable outcomes here. So in this first one right here, we know they spun 50 times, right? So the total possible is 50. How many times did they land on? It says less than 4. So that is 3, 2, and 1. Count the tally marks. 9. So tally marks on an experiment, every time they spun a 1, they put a tally mark right here. That's called a tally mark. So they got 4 times. 4 times they rolled a 1, twice they rolled a 2, and 3 times they rolled a 3. So the probability of spinning, the experimental probability, out of 50 times spun, 9 times they landed on something less than 4. Now that can not be reduced, and the instructions did not say you have to express it as a percentage. So you're done. You were saying there was 3 numbers. I got you. Yep, you got to look at that frequency or those tally marks. All right, so how about let's skip down to multiples of 4. I'm going to skip number 7 because I think you're good with 10 and 11, 10 or 11. So let's look at multiples of 4. Well, first of all, let's highlight which ones are multiples of 4. 4, good. 8. 1 isn't a multiple of 4. I got you. Numbers that are multiples of 4. We got 4, 8, good. 12 and 16. So add up those tally marks. What do we get? Good. 10 over 50. And those are both divisible by 10. So we reduce that to 1 over 5, and we don't have to make it a percentage. So we're done. Okay. I think we're good. I don't need to do this not shaded. What you would basically do is come up here, find the ones right here that are not shaded, and then count up the tally marks of 2, 3, 4, 5, 6, 7, and 8. Okay, but I'm not going to take the time to do that one because I think you guys have got this pretty good. Everybody's answering the questions perfectly. All right, let's flip over to the back, and we've got a little bit, it's counting outcomes and then probabilities of events rather than just a single spin. And so we're going to talk about how we've got events that you've got 2 or 3 things happening instead of just one spinner. Okay, so first let's look at how to tally the total number of outcomes for a situation. I can't do these. I'm just telling you, I can't do these without writing out the situation. And I'll show you what I mean here in a second. So we've got Joan randomly dials a 7-digit number. Well, I'm going to actually put each time. So her first digit, her second digit, her third, her fourth, her fifth, her sixth, and her 7th, right? She's got 7 times she's going to punch in a number. The first time she punches in a number, thinking about a keypad or a phone dial, how many possible numbers are there? There's 10. Yep, there's a 0 in there. The second dial, do any of them disappear? She still has 10, right? So for each one of these, she has the chance of hitting any one of 10 numbers. To find outcome or possible outcome, you multiply all of these chances. And you can either put it in your calculator, 10 times 10 times 10 times 10, or you can put 10 raised to the 7th power. It doesn't matter. It means the exact same thing. So everybody punch that into their calculator, whichever way you're going to do it. Yep, it's 10 million. And you're going to lay, these are story problems. So we're going to label this. It says how many outcomes. We're going to answer it 10 million outcomes. Every one of these is going to have the label outcomes. Okay. Yeah, that would be your final answer. 10 million outcomes is your final answer there. Right? Could you imagine? Yes. All right. So first year students out of school must choose one of each between 5 English classes, 4 history, 5 math, and 3 phys ed. So we're going to put our English possibilities, which are 5, our history possibilities, which are 4, our math possibilities, which are 5, and our PE possibilities, which are 3. So this is all of our combination possibilities. So we're going to put multiplication in between each one of these. So in your calculator, you're going to take 5 times 4 times 5 times 3. And we're get 300 what? Outcomes. Good. 300 outcomes. Okay. All right. 1 card each is drawn from 4 different standard decks of cards. So we've got 4 decks of cards. We've got deck 1. Yes, sir. So we've got deck 1, deck 2, deck 3, deck 4. So if I hand Blake a fresh deck of cards and I tell him to pick 1 card at random, how many choices does he have, or how many possible outcomes? 52. Now I put that deck away and I get a brand new fresh deck. Damien, how many choices do you have? 52. Notice what's important here, and I'm going to tell you this because this will trip you up. Okay, so pay attention here. Different decks. Because that's important, because if I hand Blake deck 1 and he takes 1 card out, I keep that same deck and I have Braylon pick a card. What are her choices now? Nope, you had 52, but you took 1. So now she only has 51. See how it makes a difference? If I use the same deck, your chances are 52 times 51 times 50 times 49. But in this case, they're different decks each time. Sophia? I would probably kind of make a mental note, because I don't know that would be information given to you on the iLearn. Just kind of meant the ones you normally see are deck of cards, which would be 52, a standard dice, which has 6 sides, a coin has 2. I'm trying to think of other ones we might see. I think one of the only other ones I saw was you've got 12 months and you've got 2 options each month. So it's a number of months versus times 2. And so it would be 12 times 2. So, but usually cards, dice, and coins are usually the ones you see in story problems. So, all right. So what is 52 times itself 4 times? What is it? It's not 52 times 4. It's 52 times 52 times 52. 7,311,616. And then you're going to write outcomes. Good. All right. I'm going to skip numbers 4 and 5. We might come back to them, but I want to make sure we get a chance to do these multiple event ones. Okay. So a number cube is rolled. What is the probability of rolling 4 or lower? So first of all, we need to know how many sides are there on a standard cube? 6. Okay. Now, what is the probability of rolling a 4 or lower, which means 4 can be part of it? Good, 4. This is just a standard one to kind of remind you. This is really from yesterday or from the other side. This is just a little bit of a review. Reduce that to 2/3. Okay, there's our answer there. Now we've got a multiple things happening. Okay, we have an 8-sided dice rolled. Okay, so here's our dice. It is 8-sided. And we have a coin tossed, which has 2 sides. So first of all, what is our total outcomes here? 16. Now that's only half of our answer, because we know the total outcomes, but then it goes on to ask, what is the probability of landing on an even number and getting heads? So this is how I have to do these. Again, I'm a very visual person. If you don't want to take the time, if you can do it mathematically, that's great. I've got a dice that is 8-sided, and I'm going to flip a coin. So if I roll a 1, I could get a head or a tail for the 1. If I roll a 2, I could get a head or a tail and a 2. If I roll a 3, head or a tail, a 4, head or a tail, a 5, head or a tail. These are my possible outcomes. Head or a tail, head or a tail, head or a tail, right? Every time I roll, I'm going to roll a number, and I'm either going to roll a head or a tail. Which ones of these are even numbers and heads? 2 in heads, 4 in heads, 6 in heads, 8 in heads, right? So of my 16 possible outcomes, only 4 of them can I roll an even number and heads. So first, when you have this multiple event happening, first you have to find the total number of outcomes possible. Then you have to find the probability of the very specific favorable event they're asking you about. All right, so let's see. What is the probability of landing even numbers and getting heads? Okay, now if you wanted to, okay, you could do this mathematically by saying on the die, okay, on the die, what is the favorable outcome of getting an even number? It is 4, right? On the coin, What is the favorable outcome of getting ahead? It's 1. 4 times 1 is 4. So if you want to do it visually, which is this, and actually draw it out, or if you want to do it mathematically, you can do it mathematically. Either way works, whichever way. Everybody's brain works different, so I try to show both ways, okay? Okay, let's look at how many fruit smoothies are possible. And we have 6 choices of fruit, 4 choices of milk, and 3 different sizes. Okay, this is very easy to do, and I'll show you how. Your choices of fruit, oops, I don't know why I put an E on the end of fruit, are 6. Our choices of milk are 4. Our choices of size are 3. Just multiply those. This just wants total outcome. It doesn't say what is the probability of getting a strawberry almond milk in a small, right? It's just wanting total outcome possibilities, which would be what? 72 what? Yeah. How many total possibilities are there? All you need is the total outcome. Honestly, the difficulty in this section or in this little 6.6 and or 13.6 and 13.8 is just figuring out what they're asking. Are they wanting just the total outcome and you don't have a more specific probability? Or are they wanting something specific? Number 9 was something specific, which is why we had to find total outcome first, then narrow it down to a very specific favorable outcome. Number 7 and number 11 were not like that. Number 5 is very much like that as well. And we've got time, so I'll just run over this real quick. You've got a sweater comes in wool or fleece. Okay, there's 2 outcomes there. It comes with a zipper or a neck, crew neck. There's 2 outcomes there. And it comes in 3 colors. So you can have wool or fleece, zipper or crew, and then times the 3 colors. And so your possible outcomes here would be 12 outcomes. Make sense? It does not ask for a more tighter, okay, now that you've got all the outcomes possible, it doesn't ask what are the chances of getting a wool crew neck in blue, right? So you just got to know when to stay broad, and then you got to know when to hone in on a very favorable outcome. And that just comes from reading the problems a couple times. Honestly, yesterday I had to read each one a couple of times to kind of figure it out, but it eventually got there. All right, for those of you at home, click on Cami, do all the ones left because I whited out the ones I wanted you to skip, and email me if you have any questions.